So the next note section we're going to get into is air masses and fronts, and how the movement of air along with the amount of moisture in the air really gives an indication of the type of weather that we get in a certain localized area. So for us here in Pennsylvania, Boyertown to be specific, we get certain types of air fronts that move through, and sometimes they're cold and sometimes they're warm. More often than not, they have moisture in them. They're very rarely, you have a lot of dry air. So the reason is because there are centralized air masses that will move and shift all over the United States, and when they do, they create different types of weather in their movement. So to understand the idea of air masses and how they move across the United States, we have to define what an air mass is. So first of all, just note that there are 6 air masses that affect the United States. You kind of saw it in the picture on my first slide, but we're going to create that picture so we get a better understanding of the 6 air masses. An air mass basically is a large section of air that has 2 characteristics that are similar: temperature and amount of moisture, if any. Because there are some air masses that are dry because they're formed not over water, but they form over land. But the similar temperature has to deal with where it's cold on the earth and where it's warm on the earth, and then how those air masses affect and move other areas. Now remember, global winds kind of ties into that. The jet stream can tie into this. So things to kind of remember. So to identify, remember these previous things that we've studied. First, air from the north is cooler and air from the south is warmer because more sunlight hits the south of us and less sunlight, direct sunlight, hits north of us. And there's times of the year that the North Pole gets no sunlight, so therefore no heat. So those areas in the wintertime are generally a lot colder north of us than it is where we are. And to the south of us, since they're getting such direct light all the time, it's usually characterized as more warmer weather. So to continue, when we're talking about air masses, there's ways air masses are classified. 2 of the classifications are going to be dealing with temperature, and the other are going to be dealing with moisture. So, and they are identified by where they're coming from. So if an air mass forms over water, obviously the amount of moisture that's in the air mass is going to be more of a wet, what we call a maritime type of air mass. If the air mass forms over the land, that's dry area, so we call that a continental air mass because it's forming over a drier region. If the air mass is forming to the north part of the country, that's colder region, therefore we consider that polar air mass. And if it's to the south of us, we call that a tropical air mass because it's warmer climates. So knowing these terms, polar, tropical, maritime, and continental, gives you an idea to, what type of air masses we're talking about. So 2 of these words at all times get combined to explain the air mass. Since air masses deal with temperature and they deal with moisture, 2 of these words are bonded together to create that one air mass, or to name that one air mass. Let's label the map. That's the next thing we're going to do on the next page. So you were given a map also as a separate sheet. So as I do the map on the screen, try to label the map on your own to map out all 6 air masses that affect the United States. Okay, since this is a map and I'm going to be drawing it, of course I'm going to be doing this in one take. I'm not going to keep stopping and starting, and I'm not going to be able to keep stopping and starting the movie. So this is going to be one take as I do this. So if I screw up or I stumble on my words, I do apologize. So we're going to start with the polar air masses first. Polar being that they're colder air masses. So I'm going to use blue as my polar air mass, just to kind of give you an idea of where they're forming, where they're coming from, and how they affect the United States and how they move. Remember, westerlies will move winds, air, and the jet stream will move in this direction as I draw my arrow. So let me get rid of the arrow there. So polar air masses, there's one that forms over this region, and it moves kind of this way downward towards the United States. This is a cooler air mass that is also formed somewhat over water, so therefore we call this a maritime polar air mass. So this air mass that forms from here that can affect our weather. Sometimes we get weather from the north and the northeast. Sometimes that can happen because if a jet stream drops down and the air below it doesn't move the way the global winds do, the air mass can drop down in our location. and that's considered a maritime polar air mass. There's one in the middle of the country. A lot of times when we get our colder weather, we're getting it from Canada, and since this is a drier but colder air mass, we call that a continental polar air mass. There's a third air mass that forms from the north. So the third one, as you see, is forming over water, so we got to call it maritime. And since it's coming from the north, it's a polar, colder air mass, and that will affect the United States like that. So these air masses don't just stay in place, they move and they shift all over. And sometimes air masses will take over other air masses, push some of the other air masses out of the way, and be the more dominant air mass. The jet stream can control that, global winds can control that, or the movement of the air mass itself can control that. So the three polar air masses are two maritime polar on the outer edges of the United States, and one continental polar because that air mass is formed over land. Now, the tropical air masses, which there are three, again, similar locations, just south. So since they're coming from southern areas, they're going to be much warmer. This is forming over water, so we'll call this maritime. But now it's not maritime polar, it's maritime tropical. So this air is usually a lot warmer coming from this air mass that's affecting the United States. There's another air mass that kind of sits in here between Mexico and the United States. And since it's forming majority over land, it's considered continental. And since it's from a warmer region, it's considered tropical. Therefore, this air mass is a continental tropical air mass. The last air mass forms kind of in this region here. It is forming over water, so therefore maritime again. And since it's south, it's tropical. So therefore, maritime tropical air mass. So these are the 6 air masses that affect the United States. We get encountered with the maritime polar. So we get this one, and we get this one, and sometimes we get the drier air coming from this one. Sometimes we get the colder, drier air coming from Canada. So these 4 can travel great distances to affect our weather here in Boyertown. But if you know the way they're moving, and the way weather maps will show them is what on the next slide is going to show you, they show them as lines. They don't show the entire air mass on a weather map. They show you flags or pictures that basically show how an air mass is moving. At the boundary of each of these air masses is what we're going to call a front. And on the next few slides, we're going to talk about what makes a front. So as these air masses move, the boundary between each air mass is considered a front. So a front's definition looks like this. It's basically the boundary between air masses. So a cold front is going to be part of a colder boundary, one that the polar boundaries or air masses. And then a warm front is going to obviously be one of the boundaries of the tropical air masses. And then between them, you've got your moisture, depending on whether it's tropical or not tropical, whether it's maritime or continental. Depends on what type of weather is going to happen at each of these boundaries. So a definition of a front is the boundary between air masses. And as air masses move, the stronger the air mass, the bigger air mass usually takes over or overtakes one of the other air masses. So a cold air mass can overtake a warm air mass. A warm air mass can overtake a cold air mass. It just depends which one is larger and has the more momentum of global winds or jet streams or any other type of movement that causes one to be more dominant than the other. There are a couple other fronts we're going to get into where when the 2 air masses meet, nothing happens, one doesn't overtake the other. And there's another one where you have a cold air mass overtaken by a warm air mass, but then a very quickly moving cold air mass comes in and overtakes that one. So those are 4 different types of fronts. Those fronts are considered warm, cold, stationary, and occluded, and we'll get to that in the next slides. Different types of weather are occurring at each of these fronts, and a lot of times at the front itself, it's usually precipitation of some sort. Sometimes there's thunderstorms, but a lot of times you have rain or snow depending on air temperature of what type of precipitation is actually going to fall. So in the next slides, like I said, are the 4 types of fronts. For each one, here's what I'd like you to do. In your journal, label what is taking place. So for example, warm air is overtaking cold air in a warm front, or cold air is pushing warm air up in a cold front. And describe the type of weather that can occur at this front. So the first front we're getting into is the warm front. So here's a picture of a warm front on the right-hand side. At the bottom of the slide is a symbol that they write on maps to indicate a warm front that is existing. And since warm usually comes from the south, is why this is kind of pointing in a southern direction. But sometimes it moves east and west, so it depends on the direction. They usually point the symbols the direction the air front is moving. In this case, in the picture, the warm air mass, which is less dense, sits on top of a cold air mass and just overtakes the cold air mass. Now, the warm air mass, of course, warm air is lower pressure, so a lot of times you have different air, less air molecules involved in that area, but what you do have is more chance for water vapor to take place. So you do get some drizzly rain sometimes when a warm front overtakes a cold front. So some precipitation can occur. Because what's happening at those clouds is they're condensing. The cooler air that's there, that the warm air is overtaking, is causing those clouds to form and causing that stratus cloud to take place, and it'll get a lot of rainfall that falls from at the boundary. So a warm front is usually an indication of rain, but not necessarily thunderstorms. It doesn't really create thunderstorms at the edge of this front, this boundary. But you get a lot of rain and precipitation, or snow. Depending on temperature. The temperature is around 32 degrees Fahrenheit. And after the front passes, air is typically warmer because that's the surrounding air that's left over. So we get these air masses from the south of us. So when you watch a weather map, you watch a meteorologist talk through their weather map, they'll show you how air is moving across the continent, and they'll show you the southern warmer air coming from the north and the colder air coming from the north. I said warmer air from the south. I'm pretty sure I said that right. A cold front is obviously different than a warm front, but in this time, what happens with a cold front, and you see the symbol in the picture in the diagram here, with a cold front though, cold air is more dense than warm air. So cold air that's stronger, that's more dominant, will come in and take the warm air and push it upward into the clouds. Now, what that does is it creates the clouds to become bigger and taller and larger, because that warm air is being pushed higher and higher in the sky. And the cold air that's left over is causing that condensation process to keep taking place. Now you've got not just rain clouds, you have storm clouds. You have those cumulonimbus clouds that actually form when this cold air mass overtakes. So in a cold front, a cold front is indicative, or typically there's stormy weather, again rain, because you got a lot of warm air that's being thrust up into the atmosphere very quickly. So a lot of water vapor that's being thrust to the air, and that can condense very quickly in the colder air, and they'll fall down as rain. Sometimes you get very strong thunderstorms. So on really hot, humid days, if a cold front moves through, it's very characteristic that a severe thunderstorm is going to happen. If not in this area where the overtake is being held, somewhere in our area, storms can absolutely form and be created from this front. So when on a weather map you see those bluish triangles, usually coming down from the north, it's an indication, or even from the west, it's an indication that a cold front is moving through. So like I said, they don't show the entire air mass, they just show you the boundary of the air mass when they're showing you pictures of these on these weather maps. Again, the air that's left over after the cold air mass passes through is obviously colder air, because that's the more dominant air mass that's overtaking the area, pushing all that warmer air upward away from us. Now, sometimes you have air masses that will meet and nothing will happen. One will not overtake the other. That's what's called a stationary front. And the symbol at the bottom of this slide is how they describe a stationary front. It means that cold air and warm air are pretty much at an impasse. One is not overtaking the other. Now, that changes over time. One does become more dominant, one maybe because of global winds, maybe because of the jet stream, what have you. One does become more dominant over time. At this boundary, again, you've got warm air and cold air at the boundary being pushed up into the air at the same time, creating more clouds, and generally you have a lot of rainy weather that happens in a stationary front. So you're noticing, hopefully, that at each of these front boundaries, or at each of these boundaries we call fronts, you usually have precipitation of some sort taking place at each of these fronts, whether the one air mass is stronger than the other, or that they're stationary like this map shows you here. Finally, the occluded front, which happens from time to time. It's not very often that this occurs, but it is one of the four fronts that I want to get into. So as you see the picture on the right, you've got a cold air mass that is being overtaken by a warm air mass. Now, generally, that would be just rainy weather, right? However, another cold air mass sitting behind. So, like, let's say, for example, you've got a maritime, no, you've got a, excuse me, maritime, I was right, maritime polar air mass, like the one in the upper right-hand corner, in our area. One of the warmer the maritime tropical air comes in, and then all of a sudden that continental tropical air from Canada comes in. No, continental polar air mass comes in and overtakes it. Now this scene is pretty confusing just because I screwed up that scenario. Let me simplify it. You've got a cold air mass. A warm air mass is starting to take it over. Generally, again, you get a lot of rain with that, those stratus clouds. But then all of a sudden, a faster moving cold air mass comes in and pushes that warm air directly upward. And again, we said that with a cold front. Now you're getting more warm air pushing clouds, forming clouds up in the air. You're getting a lot stronger thunderstorms in this situation because the cumulonimbus clouds are getting bigger and thicker and stronger, and usually it is what happens during an occluded front when that takes place. You get some very severe thunderstorms that can happen. Very heavy precipitation, strong storms. Sometimes you get hail with these types of fronts because the colder air is freezing, or water vapor is freezing, and it's going higher and higher in the cloud, and it's getting bigger and bigger, and then falls to the earth as hail as it gets denser and denser. So like I said, warm air mass is overtaking a colder one. Another cold air mass comes in, pushes all that warm air up into the atmosphere, creating those clouds, creating a lot of weather. That is an occluded front. The symbol, as you notice, they put red and blue together and made purple, since red and blue are primary colors. Pretty sure I'm saying that right. So a lot of times maps will put them as purple to show you that this is a mixture of the two types of fronts, and you've got an occluded front, so you've got both symbols of the warm and the cold there, the triangle and the half circle, just kind of showing you that there's a couple of air masses at work here, actually 3 air masses at work, and the 2 cold are overtaking that warm one. So that's kind of a sum up of the types of fronts, the boundaries that I have. So as we start to read maps, in the next part of this unit, as we start to predict, now you can start to see how maps are designed and drawn. Start watching some newscasts and the meteorologists and watching how they show you the Doppler and they show you how the weather is moving through. They'll show you the big map and then they'll show you a localized area. Start catching on to the idea of the fact that all this air is moving and all these air masses are moving, and the meteorologists are tracking the movement. And if they know a front is moving through, they know that weather is on the way, and different types of weather and precipitation, and their Doppler radars will show them that too. So take some time to actually watch some newscasts, and then that way you can kind of get an idea of the way to predict it, because that's what we're going to do next.